mainly 4 types of statistical measures are used to describe data. Describe the data. Now, coming to what are they? Number one, measures of frequency. Measures of frequency. Number two, measures of central tendency. Measures of central tendency. Number three, measures of variation. All of you think so, better to note down these points, very, very important. And number four, measures of position. These are the four one. Now coming to the first one, visualization. Visualization for continuous data and as well as visualization for discrete data. Visualization for continuous data and number two, visualization for discrete data. For discrete data. Now, for this visualization, generally we have to use bar charts, pie charts, histograms, and scatter plot. Scattered the plot and box plot. So many are there in which only we have to study bar chart and histogram, that are pie chart, that we have to study in our syllabus. Now coming to next topic, that is what is frequency, how to form the frequency table, and what is the frequency table and what is the class interval that we have to study. First we have to study for qualitative data. Qualitative data. Qualitative data means it defines the only quality. That means either it may be nominal or ordinal data. Nominal data or ordinal data. Now first we have to define the frequencies. A frequency distribution for qualitative data list all categories and numbers of elements that belongs to each of the categories. That belongs to each of the categories. Now that means when you define the frequency distribution for qualitative data, list all categories. Suppose A, B, C or three categories are there. First we have to identify the categories and the number of elements which belongs to each category. That we have to identify. Now some crucial simple definitions or formulas we have to define here as relative frequency of a category. Relative frequency of a category is equal to frequency of that category divided by sum of all frequencies or total number of frequencies. Sum of all frequencies or total number of frequencies. And again, one more point we have to define here as percentage. Percentage is defined as the relative frequency into 100. Into 100. This is known as percentage. Okay. Now, when you are going to find out the frequency of any category of the given formula, we have to take the frequency, relative frequency means frequency of that category divided by total number of all frequencies. And coming to the percentage, percentage is equal to relative frequency into 100. And again, first we have to define the graphical representation of qualitative data. Graphical representation of qualitative data. Graphical representation of qualitative data. That means for this we have to use bar graph or pie chart. Bar graph or pie chart, or is nothing but and bar graph and pie charts. Okay. Now the bar graph and pie charts are the two types of graphs used to represent or display the qualitative data. That we have right here. The bar graph and pie chart are two types of graphs used to represent or display, represent or display qualitative data. That means for qualitative data, we have to use or represents the bar chart or pie chart. Now, what is bar chart? That we have to see. The graph made of bars, the graph made of bars whose heights represents the frequencies, whose heights represent the frequencies of respective categories is called a bar graph. Is called a bar graph or bar chart. That means the graph made of bars whose heights represents the frequencies of respective categories is called a bar graph. That is the definition of bar graph. And then next, pie chart. Pie chart. Pie chart is a circular chart is a circular chart divided into sectors. Or partitions. Divided into sectors or partitions is called a pie chart. That means pie chart is more commonly used. Pie chart is more commonly used to display percentages although it can be used to display frequencies or relative frequencies. That is the description about the pie chart. Pie chart is more commonly used to display the percentages, although it can be used to display the frequencies or relative frequencies. Now, pie chart represents the total sample or population. Pie chart represents the total sample or population That means that is the importance of the pie chart. Now, let us see some examples related to the bar graph and pie chart. Is it understand? Now, bar chart is rectangles. Pie chart is total the area is lying in the form of a circle. Now, let us see the examples related to the pie chart and bar chart. Now, note down the problem. The following data gives the following data give the results of a sample survey of three categories: A, B and C. These are the three categories. Now, the elements related to the categories are A, B, C, A, B, A, B, C, C, A, B, C, A, C, A, C, A, B, C, A, B, C, 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 A, C, C, and C. How many elements are there totally? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. That means total values are 30. Now coming to the question. Are you understanding this one? Shall I move to the next page? Is it audible?
Yes, sir.
Yes, sir. Yeah. Shall I move into the next one? Notice this problem or not?
Yes, sir.
Yeah.
Yes, sir.
Now, number 1. Prepare a frequency distribution table. Prepare a frequency distribution table. This is 1. And 2. Compute relative frequencies and percentages for all three categories: A, B, C. Number 3. What percentage of elements in the sample belongs to category B? Number 4. What percentage of the elements in this sample belongs to categories A and C? In this sample belongs to categories A and C. Number 5. Draw a bar graph of frequency distribution of the frequency distribution. Number 6. Draw a pie chart for the percentage distribution. This is the question which is related to the simple question here. Now coming to the solution of this question, see. Now first we have to observe the categories What are the categories in this problem? A, B, C. That means we have to the first table we have to take category. That means category A, category B, and category C. Now, how many times A is available in the data? That we have to count. That means which is known as a frequency. Frequency. Now, how many A's are there totally in this one? 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, 9 A's are there. And how many B's are there? 1, 2, 3, 4, 5, and 6. 6 B's are there. And how many C's are there? The remaining, I think so, 9 plus 6, 15. Remaining is equal to 15 C's are there. This is the frequency table. Category and corresponding frequency. And again, we can find the relative frequency. Relative frequency. And the next percentage. Now, how can you find the relative frequency? Total frequency is equal to sum of the frequencies is equal to 30. That is total number of frequencies is equal to 30. Total number of frequencies is equal to total number of frequencies is equal to 30. Now we can find the relative frequencies. That means the frequency related to the category divided by total number of frequency. That we have to see here. That means what is the first category? Frequency of the category A is equal to 9. Total frequency is equal to 30. Therefore, 9 by 30. And simplifying this one, what is this value? 0.3. Is it right? Then next 6 by second one 30. 6 by 30 is equal to, on simplifying this one, this is equal to 0.2. Then next 15 by 30. Therefore, its value is equal to 0.5. These are the relative frequencies. Relative frequencies. We have right here relative frequencies are 0.3, 0.2 and 0.5. Okay. And then next, what is the next one? We can prepare the frequency table and compute the relative frequencies. Question 1, question 2 is over. Coming to the third one, we need to find out the percentages. Percentages. How can you find the percentages? Relative frequency into 100. Relative frequency into 100 is equal to relative frequency into 100 is equal to percentage. That is 0.3 into 100 is equal to 30. 0.2 into 100 is equal to 20. 0.5 into 100 is equal to 50. This is the percentages. Now we can see what is next question in the problem. What is the next one? What percentage of elements in the sample belongs to category B? Category B, how much percentage is there? 20%. Okay, 20% of elements are belongs to the category B. And what is the next one? This is question, I think the third one. Third answer. And what about the fourth one? What percentage of elements in this sample belongs to category A or C? Category A is equal to 30% plus category C is equal to 50%. Total is equal to 80%. That means 80% of elements in the sample belongs to category C. 80% of elements in this category are belongs to category A and C. Now coming to the fifth one. What is the fifth one? To draw bar chart. Now see bar chart. bar graph. What is the principle of the bar graph? That we have to take the categories on x-axis and frequencies on y-axis. This is categories. This is frequencies. Now frequency is how many? What is the minimum value and what is the maximum value? Maximum frequency is equal to 16. Therefore, we have 15. Therefore, we have to take up to 16. That means 0, 4, 8, 0, 4, 8, then 12, then 16. For convenient purpose, you have to take like this. And categories is equal to 1 is A, B and C. What is category A? How much percentage category A? What is the value in category A? What is the frequency of category A? Category A is equal to 9. Category B is equal to 6. Category C is equal to 15. That we have to draw like this. Category A 9. You have to take up to 8, 9. This is category A. And category B is equal to 6. This is 6. And category C is equal to 50. It's very simple. I think all are known this one in the 10th class or 9th class level. Is it right? The only thing is, here we have to recall that subject. This is bar graph. And again, we have to draw the pie chart. What are the percentages? Category A 30%, category B 20%, category C 50%. Now we have to take the circle. That is 50%. And one is 20% and other is 30%. This is 20%. This is 30%. This is 50%. We have to make the different colors or different ways like this. This is the pie chart. Or you have to distinguish the different colors also. You have to show this. Okay, this is the bar graph and pie chart. Note on this the example, all of you. Is there any doubt?
No, sir.
Show with the different color possible. I am not familiar of all things. That's why it takes time to me for drawing like this. And one more color I have is okay. And another one I have to take different color as green. Or same color. But then it is easily visible to the. That means pie chart is very visible chart. Easily understand what percentage of the things or categories are distinguished in the 3 types or 4 types or X like this. When you observe the pie chart, immediately we say that this is the category C, and this is the category A, and this is the category B like this. It consisting the 50%, more than half, more than exactly 50% is half of one, and this is 30%, and it is 20%. That is the very useful method we have to use by carrying out these type. Okay. Then again, moving to the graphical representation of quantitative data. Okay, shall I move into the next topic? Graphical representation, quantitative data. Shall I change the slide? Respond anyone? Can I change, move into the next slide?
Yes, sir.
Yes, sir.
Now, graphical representation of, previously we studied the graphical representation of qualitative data. Now we are going to study the graphical representation of quantitative data. That means qualitative. Quantitative means it defines in terms of numbers. Graphical representation of graphical graphical representation of quantitative data. Graphical representation of quantitative. Quantity means it is having the numbers. Graphical representation of quantitative numbers. That means a frequency distribution for quantitative data is all. Yes, unmute please. All of you mute your mics.
G5 mute your microphone.
Now, a frequency distribution for quantitative data lists of all classes and the number of values that belongs to each class. That is very, very frequency distribution a frequency distribution for quantitative data lists of all the classes and the number of values that belongs to that belongs to each class. Now, this is the very, very important representation of graphical representation of qualitative. A frequency distribution for quantitative data Lists of all classes and numbers of values that belongs to each class. Now, data presented in the form of frequency distributions called as grouped data. This is one more definition. Grouped and ungrouped. Grouped data. Data presented in the form of a frequency distribution are called grouped data. Are called group data. And already the students are known class interval, lower mark of the class, upper mark of the class, and midpoint of the class, and relative frequency and percentage of this one. And before going to note down the histogram, we have to define the frequency table. We have to define the frequency table. That is very, very important in this section. What is frequency table? What is the definition of frequency table? Frequency table means a table showing the distribution of the frequencies in different classes called the frequency table. That is very, very important. A table showing the distribution of the frequencies in the different classes is called frequency table. A table showing the distribution showing the distribution of the frequencies is in the different classes. Different classes is called frequency table. That means it is consisting the frequencies of different classes. Frequencies in the different classes is called the frequency table. Okay, that is the definition of the frequency table. Now, see, observe, these are the types of some classes. The classes of the type so generally we have to observe this one, all of you known 15 to 19, then 20 to 24, then 25 to 29, etc., like this, in which both upper and lower limits are included. This is very, very important. In which both upper and lower limits are included. So included means both upper limit and lower limit, both are included in the class interval. Therefore, we say that this type of class intervals are known as inclusive classes. Inclusive classes. This is very, very important. These type of class intervals are known as inclusive classes, are called inclusive classes. And while drawing the distribution in the class intervals, the following points are very, very important. That points that you have to keep in mind also. Number one, very, very important points. Number one, the classes should be clearly defined. The classes should be clearly defined. No ambiguity. Clearly defined. That is the first point. Coming to the second point, the classes should be exhaustive. The classes should be exhaustive. What is the meaning of exhaustive here? Each of the given values should be included in one class. Suppose you have to take one value that should be either in the upper class or any one of the classes. The number should not be taken into two classes also. That is very, very important. And coming to the third one, the classes should be mutually exclusive. The classes should be mutually exclusive. Mutually exclusive and non-overlapping. Mutually exclusive and non-overlapping. And the classes should be of equal width. This is sometimes it is not possible. The classes should be of equal width. Sometimes it is not possible. Unequal width class intervals are also taken some of the investigators. Sometimes it is not possible. And the number of classes should be taken preferably between 5 to 15. You should not take less than 5 and not more than 15. Generally, how many class intervals that you have to take for in the raw data means you have to take the class interval should be, the interval should be, when we are going to count it, that 1, 2, 3, 4 like that, it should be lies between 5 and 15. That we have to check for each and every class interval of the given data. Now, tomorrow we can define the exclusive class intervals. How we are going to take exclusive class intervals? What is the importance of exclusive class intervals? Under what data and what are considered